picture a steering committee room, right? It's a Tuesday morning.
Oh, I can picture it.
Yeah, and about 4 months ago, in this exact same room, a development team presented this brand new AI agent pilot.
Right.
And the demo, I mean, it completely dazzled everyone. The word transformational was just getting thrown around by all the executives.
Of course it was. It always is.
Exactly. So a hefty budget line gets approved with this massive stamp of enthusiasm. But today there is a very specific, very uncomfortable silence kind of settling over that room.
Because nothing actually shipped.
Because absolutely nothing has shipped. That transformational AI agent, it's currently sitting in a digital sandbox that like maybe 3 developers have the password for.
Yeah, just quietly accruing massive cloud computing costs.
Right. And generating absolutely zero revenue.
It is arguably the most expensive silence in enterprise technology right now. And I think the truly alarming part is just how common that exact scene has become across the corporate world.
Yeah, which brings us to today's deep dive. Welcome, everyone. Our mission today is to uncover exactly why enterprise AI agent pilots are just, dying on the vine.
Yeah.
And much more importantly, we're going to look at how to build them so they actually survive the harsh realities of the real world.
Which is desperately needed right now.
It totally is. And to do this, we are drawing heavily on a really fascinating new report. It's called the Enterprise AI Pilot to Production Playbook 2026.
A great read, by the way.
Oh, it's incredible. And we have to give full credit here to the authors. This was published by the Agentics. They are an Amsterdam-based enterprise AI transformation firm, and they specialize specifically in agentic AI and multi-agent systems, or MAS.
Right, and their client list is it's massive.
It is. They partner with leaders across CPG, retail, FMCG, direct-to-consumer, automotive, healthcare, energy, manufacturing, logistics, and the BFSI sectors.
So basically, they've seen it all. They have this massive global data set on what actually happens when you try to take an AI agent out of the lab and put it into the wild.
Exactly. But before we get into the failures, let's just make sure we are all on the same page here. When we talk about agentic AI and multi-agent systems, we aren't just talking about, typing a prompt into a standard chatbot and getting a poem back, right?
No, not at all. I mean, think of a standard chatbot as a highly intelligent encyclopedia. You ask it a question, it gives you an answer, and it stops.
Right.
Agentic AI takes that reasoning engine and, well, it gives it hands. You give an agent a high-level goal, like resolve this customer shipping delay.
Okay.
And the agent can break that goal down into steps. It can search databases, trigger emails, and actually execute software actions on your behalf without you holding its hand.
Wow.
And then a multi-agent system takes that a step further. It's an entire team of these specialized agents working together, handing tasks off to each other, much like a human department would.
Okay, that context makes this next statistic even more wild. Let me lay this on you. Independent studies from 2026 show that while 97% of executives report deploying AI agents,
97%.
basically everyone, but the pilot to production failure rate is roughly 86%.
It's brutal.
Nearly 9 out of 10 projects just quietly disappear before they ever touch a real customer. Okay, let's unpack this, because if almost 9 out of 10 projects are failing, we have to ask if the technology itself is just fundamentally immature. Like, are we trying to build skyscrapers out of wet clay here?
Well, when a pilot stalls out, interrogating the technology is the very first thing leadership does.
Naturally.
Right. They ask if the underlying model was accurate enough, or if the training data was too messy, or if they just picked the wrong vendor. But the Agentics research points out quite forcefully that interrogating the tech guarantees your next pilot will fail for the exact same reason.
Wait, really?
Yeah, he'll just be wearing a different technical costume. The AI models themselves work. The failure is entirely structural. What breaks isn't the AI. What breaks is the operating models surrounding the AI.
So it's not that the engine is broken. It's like we bought a state-of-the-art jet engine, but we bolted it onto a wooden horse-drawn carriage, and we're sitting there in the driver's seat wondering why the whole thing is rattling to pieces.
That's exactly it. The chassis just isn't built for the engine.
Wow.
The Agentics actually spent the last 2 years conducting post-mortems on these stalled engagements across Europe, the Middle East, Africa, and APAC. And they watched the exact same structural flaws bring down pilots over and over again.
That's insane.
But there is a massive silver lining here. If a failure mode is consistently predictable across all those different industries and regions, it means it is designable. You can architect a system that bypasses the trap.
Which means we can actually map these invisible structural traps.
Exactly. This raises an important question, though. What are the specific failure modes?
Right, and the research identifies 6 specific reasons these pilots die on the way to production. But there's a really crucial insight right at the top of the data. The uncomfortable truth, I guess you could call it.
Yeah, the two-thirds rule.
Yes. You don't even have to fix all 6 to save your project. If you just fix the first 3 structural traps, you have effectively addressed roughly 2/3 of your overall risk.
Getting those first 3 right essentially gives you a functional shield against the vast majority of pilot mortality.
That is so reassuring. So I imagine the first trap begins right at the starting line in how the pilot is actually conceived by the team building it.
You're hitting on the core issue there.
Yeah.
The very first trap is that the pilot is built as a demo rather than a genuine first phase of a production system.
Okay, what does that mean in practice?
Well, development teams are often under immense pressure to secure funding, right? So they optimize their build for the applause of the steering committee.
Of course. They want the wow factor.
Exactly. They feed the agent perfectly clean, historical data. They design for the happy paths, where the hypothetical customer does exactly what they're supposed to do. Essentially, they build a shiny, fragile toy.
But I have to ask, isn't that kind of the point of a pilot? I mean, to demonstrate the art of the possible. If you don't dazzle the steering committee, you don't get the budget to build the real thing.
It's a fair point, but there is a big difference between proving feasibility and building an illusion.
Okay, fair enough.
Imagine a retail company building a supply chain agent. For the demo, they feed it perfectly formatted, historical CSV files, and the agent flawlessly predicts inventory needs. The executives applaud.
Everyone is happy?
Right. But in production, real suppliers don't send perfect CSVs.
No, they send handwritten PDF invoices with, like, coffee stains on them.
Exactly. Or they send an email with missing part numbers. And because the team built for applause, they never designed error handling for messy inputs. The second the agent hits real-world traffic, it shatters.
Oh, wow. So what's the fix?
The fix requires writing a production definition first. Before a single line of logic is coded, the team must define what ready-to-ship means in strictly measurable, chaotic, real-world terms.
So you have to know exactly what kind of beating the agent needs to survive before you even sketch it out.
Precisely.
Okay, let's say a team actually does that. They build a robust first phase, it handles the messy PDF invoices, and the pilot period wraps up. How do they actually prove to the business that it's doing a good job?
Well, that leads directly to the second massive trap, which is the evaluation gap.
The evaluation gap.
Yeah, there is often absolutely no agreed-upon definition of good enough.
Wait, traditional machine learning didn't really have this problem, did it? Like, if I build an ML model to detect credit card fraud, it's pretty simple. It either correctly flagged the fraudulent transaction or it didn't.
Right, it's binary.
Exactly, it's binary. So why is evaluating an AI agent suddenly this ambiguous existential crisis for a company?
Because traditional machine learning is just classifying a single static moment.
Yeah.
Like you said, fraud or no fraud. But remember our definition of an AI agent from earlier.
It's doing multiple steps.
Right? It's executing a multi-step process. It has ambiguous success criteria, and its behavior is highly context-dependent. In the rush to adopt AI in 2025 and 2026, the industry took this massive evaluation shortcut.
Which was?
Teams define success simply by asking, did the agent finish the task?
But just because it finished doesn't mean it didn't, alienate a high-value client or offer them a ridiculous 80% discount just to make them go away.
Exactly. Did it finish is fundamentally different from did it finish well.
Oh, that makes so much sense.
Let's look at a concrete scenario. Say you deploy a customer service agent to handle returns. A customer initiates a return, and the agent successfully processes it. The dashboard shows a completed task.
High fives all around.
Right. But if you look under the hood, the agent might have made 45 redundant API calls, queried the database 10 times unnecessarily, and consumed massive amounts of token context. That single successful task might have cost you $2 in compute power. Meanwhile, a human operator could have resolved that same ticket in 2 minutes at a labor cost of $1.50.
Oh, wow. So the agent finished the task, but it entirely failed the business case.
Yes. The dashboard says success, but the CFO says we're bleeding money.
That is wild. So you really have to measure the cost per successful task against a human baseline, not just the cost per attempt.
Exactly. And without those evaluation thresholds established using both offline testing and online measurement, Nobody in the organization can honestly say if the agent is ready for the public. So the project just stalls in indefinite review.
Which perfectly sets up the third trap.
It really does.
Because let's say you've built a robust system, you have concrete math proving the cost per successful task is profitable. You're ready to flip the switch. When do the lawyers get invited to the party?
Usually right about now, which is far, far too late.
I knew it.
The third trap is bringing governance and compliance in as an afterthought.
Right.
If we connect this to the bigger picture, you have to look at the current regulatory landscape. Particularly in the EU, the AI Act's core obligations apply from August 2026.
Which is huge.
It's massive. Teams will build an agent, love the results, and then walk it over to the risk and compliance department. And the project instantly freezes for 6 months, while legal scrambles to understand what this black box is actually doing.
I can hear the developers groaning already. But you're saying that engaging governance late isn't just an operational slowdown anymore.
No, it is a massive legal and financial exposure. Governance must be built into the pilot from week one. When a pilot moves toward production, risk teams need answers to very difficult questions.
Like what?
Like, what is this agent allowed to do without human approval? Who holds the liability when it makes a mistake? What is the exact protocol when it fails?
So it's not just a rubber stamp at the end.
Not at all. You have to classify the risk tier and define human oversight checkpoints during the design phase.
What does a human oversight checkpoint actually look like in practice, though? Are we talking about, like, a manager standing over a server farm?
No. It's hard-coded logic.
Yeah.
If you are building an agent to handle customer refunds, you might design a software constraint that says the agent can autonomously process any refund under $50.
Okay.
But the second a customer requests a refund of $51, the agent halts its autonomous execution, drafts a proposed resolution, and drops it into a queue for a human manager to click approve or deny.
Oh, I see.
And if you try to retroactively wire those checkpoints into an agent after it's fully built, you end up breaking the system. It has to be part of the foundational architecture.
Okay, so those are the big three: the demo trap, the evaluation gap, and late governance.
Right.
And if a team navigates those, they've eliminated roughly 2/3 of the risk. They've survived the initial gauntlet. So let's look past the launch. The confetti is settled. The agent is live on day one. What happens when this hyper-advanced technology actually interacts with existing corporate workflows on day two?
Well, that's when you step right into trap number 4, which is layering an agent onto a broken process.
Here's where it gets really interesting.
It is a classic mistake of treating an operations problem like a technology problem. Think about how many corporate processes are currently held together by what the report beautifully calls human error workarounds.
Oh, I know exactly what you mean. The classic, Dave in accounting always exports this database to a CSV, manually deletes row 4 because the formatting is weird, and then emails it to Sarah because our two legacy software systems refuse to talk to each other.
Yes, exactly that. And if you take an AI agent and drop it into that exact same workflow, you are forcing advanced technology to inherit Dave's weird spreadsheet workaround.
So the AI is just sitting there deleting row 4.
Exactly. The agent exports the CSV and looks for row 4. But the irony is, automating a broken workflow doesn't fix it. It just gives you a significantly faster broken workflow.
I have to push back here, though. Redesigning a core business process, like how a company handles its entire supply chain, procurement, or accounting, that can take years and millions of dollars in change management consulting.
Yeah.
Are you seriously saying a company can't deploy a single AI agent until they entirely fix their legacy business architecture?
No, you don't have to boil the ocean. But you absolutely have to redesign the specific workflow the agent is going to own.
Okay, how does that work?
Going back to your Dave in accounting example, you don't need to overhaul the entire finance department. Before you build the agent, you ask, if we were designing this one specific task from scratch, knowing an AI could use APIs, what would it look like?
I see.
The redesign process probably involves the agent querying the SQL database directly and sending a clean data packet to Sarah's software, skipping the CSV and the email entirely.
Wow, so you simplify a 12-step human workaround into a 3-step agent process?
Exactly. You have to strip away the human error workarounds for that specific task before you automate it.
That makes a lot more sense. You're clearing the brush on the specific path the agent is going to walk. But what about the team itself? I can see how a pilot gets built with massive enthusiasm. The developers are pulling all-nighters. But once the pilot actually launches, Well, those developers usually get reassigned to the next shiny project, right? Does this thing just run itself?
You've just diagnosed trap number 5, the orphaned agent.
The orphaned agent.
Yeah, during a pilot, ownership is implicit. The build team owns it because they're actively writing the code. But the build team is rarely the long-term run team.
Right.
Once the agent is deployed, if a formal handoff isn't clearly defined, an accountability vacuum forms overnight.
Because an AI agent isn't a piece of static software. You don't just compile it, ship it, and forget about it like an old calculator app.
Exactly. Who owns the agent 3 months from now when its underlying large language model receives a silent update from the vendor, and the agent's behavior subtly begins to drift?
Oh, that's a good point.
Who owns the incident response when it misbehaves? Who is monitoring the daily cloud costs? If nobody is formally named, the agent just sits there slowly degrading until it causes a crisis or is quietly turned off.
So a production owner, like one accountable person or function, must be named on day 1 of the pilot, not discovered in a panic on day 90 when something breaks.
Precisely.
An accountability vacuum? That is incredibly dangerous in an enterprise setting. But how would that production owner even know if the agent was drifting or failing? Doesn't the IT department have dashboards that show if a software application is healthy or not? If the server's up, it's green, right?
That assumption is the final trap. Unmeasured reliability.
Okay.
What's fascinating here is our legacy IT monitoring tools actively deceive us when it comes to agents. Legacy application monitoring was built for deterministic systems. If you put the exact same input in, you get the exact same output out.
Right.
If the server is up and the latency is low, the dashboard shows a green check mark and you assume everything is fine.
But agents aren't deterministic, like you said earlier. They are probabilistic. They make dynamic decisions on the fly. Let's get really concrete here. How can an agent look totally healthy on an IT dashboard but still be failing the business?
It's actually terrifyingly easy. An agent can return a response to a customer with absolute zero latency. It can trigger zero standard error codes. The legacy IT dashboard will be glowing green.
Sounds perfect.
Right. And yet, that same agent might have completely hallucinated a factual policy, chosen the wrong internal software tool to pull customer data from, or quietly corrupted a downstream database record while trying to be helpful.
Oh, wow. So it's cheerfully and efficiently doing the wrong thing.
Exactly. If you try to run an AI agent on a legacy monitoring stack, you literally cannot see what the agent actually did under the hood.
Yeah.
You have to instrument specialized observability from day one.
What does that entail?
You need to track full execution traces, meaning every single step of logic the agent took. You need to monitor tool call success rates, not just overall latency, because what isn't measured cannot be trusted.
And what cannot be trusted absolutely cannot be scaled across a business.
Exactly.
Okay, we have officially mapped the structural traps, the urge to build a fragile demo, the ambiguous evaluation gap, late governance, layering an agent on a broken process, the orphaned agent handoff, and unmeasured reliability. I'll be honest, this sounds exhausting. It sounds like a total minefield. How does an organization actually survive this?
Well, this is where we look at the solution, specifically the validation-first framework pioneered by the Agentics.
Okay, the validation first framework.
Yeah, it's a complete paradigm shift in how these projects are run. Instead of building an agent and then scrambling to figure out how to control it or evaluate it, you build the oversight, the evaluation thresholds, and the escalation paths before you overrate the agent's core logic.
But I have to play devil's advocate here. If you force a development team to figure out legal oversight, perfect evaluation metrics, and workflow redesigns before they are even allowed to start coding, doesn't that just paralyze the project? Doesn't it slow everything down to a crawl?
It feels counterintuitive, but it actually speeds the path to real value. It functions like a strict pre-flight checklist. The agent does not earn the right to advance to production until it clears all these design constraints.
I see.
And none of these constraints are particularly expensive or time-consuming to implement if you do them at the beginning when the canvas is blank.
Right.
What is expensive and what slows a company down is discovering you need all these things 4 months later when the sunk cost is massive, the political capital in the company is totally spent, and you had to have a very difficult conversation with the steering committee about why their transformational AI is a zombie.
That makes a lot of sense. The cost of preventing a tangled mess is pennies compared to the cost of untangling it later.
Exactly.
So what does this all mean? Like, if an organization actually has the discipline to use this validation-first approach, what are the actual economics? We spent all this time talking about the 86% failure rate. What does the promised land look like for the minority who get it right?
The economics are incredibly favorable. By applying this framework, the Agentics is able to implement AI solutions that deliver measurable ROI within 6 to 12 months.
6 to 12 months, that's fast.
It is. And if we look at broader 2026 benchmark data, where use cases are narrow and well-chosen, the payback period is astonishingly fast. We're talking a median payback of roughly 4 months for customer service workflows.
Wow.
Yeah, it's about 7 months for marketing operations and 9 months for complex engineering workflow.
4 months to completely pay back the investment on a customer service agent. In the timeline of enterprise software deployments, 4 months is practically overnight.
It is overnight. Because a contained customer service ticket that is successfully resolved by a well-designed agent costs just a fraction of the human-handled equivalent.
Right.
When you look at the average enterprise agent ROI reported across these surveys, it sits near 171%.
That is huge.
The financial value isn't theoretical anymore. It is intensely real, and it arrives very quickly for the organizations that get the structure right. The technology has been ready for a while. It is the discipline to implement these structural safeguards from week one that is scarce.
So to wrap this all up, if you take one thing away from our deep dive into this report today, let it be this. That massive 86% failure rate is not a technology problem. It is the lack of a structural operating model.
Precisely.
By utilizing a validation-first approach, organizations can bypass the urge to build a fragile demo, they can bridge the evaluation gap with real math, and they can integrate governance up front instead of as an afterthought.
Absolutely. And if you are listening to this right now, I challenge you to take a hard look at your own organization's AI pilots. Walk into work tomorrow and ask the difficult questions. Are your agents truly optimized for real-world, messy traffic, or are they just highly polished toys built to impress the steering committee? Do you have an accountable owner named for when the underlying model inevitably updates and drifts? Have you defined what good enough actually means in dollars and cents?
It really makes you rethink our entire relationship with this technology. We spend so much time in the broader culture worrying about whether AI will eventually replace human intelligence or whether these models are getting too advanced too quickly.
Yeah, that's the usual narrative.
Right, but looking at these failure modes and specifically how we force agents to navigate our own legacy workarounds, you have to wonder, are we actually holding AI back right now by forcing it to operate within broken human-era workflows that we were simply too afraid or too lazy to redesign?
That's a great question.
Think about that the next time you hear that expensive silence in the boardroom.